We're going to finish up chapter 8 now. I want to talk about Lewis structures. And again, Lewis was the guy, he really worked with electrons a lot with all kinds of stuff, but he's the one that started drawing structures so you represented where all the electrons are. And again, remember with a covalent bond, you share electrons so that everybody gets 8 unless it's hydrogen. So what he did is, again, you get the number of electrons from whatever column they are on the periodic table. Okay, column 1, column 2, and then remember you skip over to like boron and the nitrogen. So it's 3, 4, 5, 6, 7, 8. So we do the S's and the P's. Okay, so hydrogen each has 1. If you put 2 of them together, they share 2. That's what this represents a bond, and a bond is 2. So each of them have 2, and then it's good. Chlorine has 7. Okay, so 6 of its own, and then it shares 1 from this chlorine and 1 from that chlorine, and now they both have 8. So these are Lewis structures that represent the covalent bonds between, this would be H2 and this would be Cl2. Okay, and again, you have to situate them. Now these are just 2, but when you have another structure molecule, you have a central atom and you have the things that go around it. Okay, so when you're drawing Lewis structures, you're making sure everybody has 8 electrons around it, except for hydrogen, again, only has to have 2. They want to be a noble gas, is basically what they want to do. Okay, sometimes they have what they call lone pairs, especially like with the nitrogen in those group, those guys have 5 electrons. So they have 1 lone pair and then they have 3 individual pairs. And so they're going to be looking to form 3 bonds, and then they'll have that 1 pair all by itself. Okay, and then you have the bonding pairs. Okay, the pairs that are shared. Okay, in here it can be represented by 2 dots or 1 line, but you can't do both. I always do dots. It's easier for me, but again, if you have a line, that represents 2 dots. So you do one or the other. And again, I'm just all about the dots. You can do whichever you prefer. Okay? Sometimes in order to get enough electrons, it has to share more than 2. Okay? Sometimes it has to share 4, 2 from each, or even 6. Okay? Here's an example of nitrogen. Okay? Nitrogen has 5 electrons. Okay? And you have to put these 2 guys together so that they both have 8. The only way that's going to happen is leave this 1 pair here and then stick these 3 in the middle. And again, same over here, leave these 2 and stick these in the middle. So these 2 and these 3 came from this nitrogen. These 3 and these 2 came from this. And by sharing 6, now they are stable. 2, 4, 6, 8 for this nitrogen, 2, 4, 6, 8. So this is called a triple bond. Okay, here's an example of carbon dioxide. You put carbon in the middle, carbon has 4, it's looking for 2 more. Okay, and oxygen has 6, so it's looking for 2. The only way it can happen is if they share electrons. And there's a number way, I'll show you how to do this too. You can actually calculate it. Maybe it isn't as hard. Some people can just look at that and see it. Some people can't, and I'll show you a way of figuring it out by using the numbers. Okay, okay, so sometimes you need, again, a double bond. And again, this represents 4 electrons. And sometimes you need a triple bond. There's not a quadruple bond. Okay, so single, double, triple, that's it. All right, and again, when you're looking at these guys, you have, if you look here, this oxygen 2, 4, 6, that's its 6, and then it shares 2 from carbon. And this oxygen 2, 4, 6, and it shares 2 from carbon. And now if you look at the carbon, 2, 4, 6, 8. They need to have 8. So you have to situate them. But again, I'll show you a number way of figuring it out too, so you don't have to sit there and go, oh, what? Okay. All right. So here we have phosphorus and chlorine. Okay. This is the way you can do it by the numbers. Phosphorus is in group 5, so it has 5. Chlorine is in group 7. It has 7, and there's 3 of them, so altogether we have 26 electrons. That's how many we have. What we need is phosphorus needs 8, and all these chlorine need 8. So we have 4 molecules, and they each need 8. That's 32. So we need 32. We have 26. Let's see if I have that on here. No. Okay. So what I do, and they might do it, they do it, but I think they do a little bit more complicated, is I would take 32 minus 26. That means I need to share 6 electrons. So I have to situate this so it has 6 electrons, or sharing 6 electrons, okay? Well, this one's actually pretty easy. We're not going to worry about that one. Okay, if I put it like this, okay, phosphorus has 5. So I have 1, 2, 3 here, and then it would have us 2 up here as well. And then I'm just going to stick my chlorine in because chlorine has 7. So 7 here, 7 here. I wish they had the dots. And you guys, I have a video of this of me doing it. I'll show you again, make it simpler for you. Okay, so I said when I took 32 minus 26, I was sharing 6 electrons. 1, 2, 3, 4, 5, 6. So I need to form 3 bonds. Okay. Yeah, I don't like this down here, you guys. But this is what it will look. And there's one more set right here because phosphorus has 5. Did they put that on there, please? There we go. Okay. Phosphorus has 5. So these 2, and then it has 1 of its own. And then chlorine has 7. So you put them around it. Now, if you look, everybody has 8. And again, when I did this, this is how I did it. Phosphorus has 5, and each chlorine has 7. So that was 26. That's the electrons that are available to use. I need 32 because I have 1, 2, 3, 4. They each need 8. So I need 32. I take 32 minus 26. I get 6. They have to share 6 electrons. That's 3 bonds. 1, 2, 3 bonds. Okay. All right. Here's another example. We have carbon, nitrogen, and hydrogen. Carbon's in the middle. Okay. So if I use my number thing, I have 1 here for hydrogen, 4 for carbon, so that's 5, and 5 for nitrogen. Altogether, I have 10. Okay, 1 from this guy, 4 from this guy, 5 from that guy. And again, that's just whatever row they're in. So that's 10. Okay, now I need 2, and then both of these guys need 8. So 8 and 8, 16. I need 18. Okay, so I need 18. I only have 10. 18 minus 10 is 8. So that means I need to form 4 bonds. Well, I can only form 1 bond with hydrogen. That's all it'll let you do. That's all it has room for. So I must have to form a triple bond on the other side. And here's my 4 bonds. Now, if you look, hydrogen has 2. 1, 2, 3, 4. Hydrogen has 8. Nitrogen has 1, 2, and then 6 here. All of them have 8. Okay, so that's how I figured I needed to form a triple bond by 1, 4, because carbon's in the 4th group. That's 5, and then nitrogen has 5, so that's 10. But I need 2, 10, 18. This needs 8, this needs 8, and this needs 2. So that 18 minus 10 is 8. I need to form 4 bonds, 1 bond and a triple bond there. Okay. I think here it shows you the charges. Okay. And again, you can use the formal charges, but honestly, I think my number thing's a little easier to use. Okay. And again, the way I use it is I figure out what they have and what they need. And just subtract the difference between the 2 of them, and that'll tell you how many bonds you need to form. Most of them are pretty simple, you guys. Okay, sometimes you end up with structures that are a little goofy. And it's hard to see this, but this is ozone, O3. Not a common substance on Earth, really common up there. That's what protects us from the UV rays. You've probably heard of ozone depletion and all that. Okay, here's ozone. In order to be stable, if you think about it, I don't know if we have anything here. Okay, oxygen, 3 oxygen. Okay, you'd have, each of them have 6, so that's 18. Okay, but each of them need 8, so that's 24. So 24 minus 18 is 6. You need to form 3 bonds. So you need to form a double bond on one side and a single bond on the other side. So which side do you put it on? You can actually do either. These are called resonance structures. You have one over here, or you can have one over here. These 2 are resonance structures of each other because when you have a double bond on one side and a single, which side do you put it on? So you can move it, and then these 2 would be considered, they call them resonance structures of each other. Okay, because if they're both double bonds, then they wouldn't be resonance structures. But because you have a double bond and a single bond here, and a single bond and a double bond here, then you have it. You can't make 2 double bonds, because if you did that, this oxygen would have 2, 4, 6, 8. This one would have 2, 4, 6, 8, 10. This guy would have too many. So you have to have a single bond on one side and a double bond on one side and a single bond on the other. But you can move that double bond. So these are called resonance structures. Okay? Okay? They can have multiple figures, multiple ways of drawing them. There's some where you can have 3 resonance structures of each other. Okay? And again, that's when you don't have the same amount of bonds on each side. Here's another example. Here's boron fluoride. Okay? Boron has 3 and fluorine has 7. Okay, so let's do the numbers. Boron has 3, and then each fluorine has 7, so that would be 21 plus 3 would be 24. But we need 32, 8 for each. So that means I need to form 4 bonds. Well, if I do it this way, I only have 3 bonds. These guys are, the fluorine are good, but the boron isn't because it only has 2, 4, 6. It needs 8. So I can form 1 double bond. I can move 1 set in on the top. I can do it from this one, or I can do it from that one. So these are called resonance structures. They don't make a huge difference in it, and which one is, most common, whatever. But these are called resonance structures, and they have to, the double bond has to be formed in order to get 8, because boron needs 8. Everybody needs 8. Okay? And that happens when you look at the group 3, boron down. That happens with those guys. Okay? But again, how did I figure that out? Boron has 3. Each fluorine has 7, so that's 21. Plus 3 is 24. That's what I have. Now I look, I have 4 molecules. They all need 8. 8 times 4 is 32. So 32 minus 24, I need 8. I need to form 4 bonds. That's why I know 2 single and 1 double. And then everybody's happy and they're stable. Okay? But again, these would be resonance structures because you can't put a double bond on all of them. That would be too many. Just 1 double bond. So it can be here, it can be here, it can be here. Okay? And those would all be resonance structures of each other. Okay? And again, I don't know why this, I should probably take this slide out. Okay, but again, I'm filling the central atom with an octet by putting in 1 double bond. And all you have to do that is move one of these guys in. Okay? And that way the central atom has 8. That's the octet. That's the important thing. Okay? There are some that have fewer than 8. They're anomalies. And it happens. Okay? We're not going to spend a lot of time on that because, again, if we spent all the time figuring out the exceptions to the rules, we'd go crazy. So we're just going to stick to the rules. Okay? But here's some examples. This is phosphorus pentafluoride. They do some figuring so that the phosphorus actually has 5 bonds. And again, it can happen, but we're not going to worry about that. We're just going to deal with the standard. Everybody needs 8, and we're going to leave it at that. Okay? And I think we might be done. Yep. Okay. So now we're just going to start working on some Lewis structures. And again, I'll have another video. I'll show you how to draw more Lewis structures.